But I actually thought about how it felt to be a customer as well, and what we can change. And I realized that actually, as a customer in the world of model railways or model railroads that are here, I'm actually slightly bored by what the big producers make, because it's always the same stuff. In the UK, we have a famous engine called the Flying Scotsman, and there are so many models of it that frankly, I'm bored with it. But actually, the small producers, the people who make the teeny tiny interesting stuff, they actually don't serve model makers very well, in my opinion. So we wanted to try and change it. And you've got some models that are really, really ancient and they don't work that well. But on the other hand, you have, for the really big commercial models, there's been a bit of an arms race between the manufacturers and the modelers and the press, where actually things are so perfect now that the only story that you can tell is taking it out of the box and possibly breaking it as you take it out of the box. And so I wanted to see if we could change this. A friend of mine wrote this thing last year, and it got me thinking. And he thinks that making things that people want is far more important than making people want things. So 20th century has been about mass producing things and then using mass media and mass advertising to make you want it. Whereas actually, if you look around us here, it's actually about, well, what can we make that people want? How can we be a small manufacturer? How can we change the size of manufacturing? And I'll give you an example of something that I want. This is a really obscure wagon. There are 5 of these made in the world in total by one quarry in Wales. So it's really quite a niche thing. Amazingly, somebody actually came up to the booth earlier and told me what it was, which I was really surprised about. But up until last year, the best kit that you could get for it is this, which is a piece of etched brass. So amazingly, this piece of etched brass makes this 3D object. And it's kind of like origami, putting it together. But it's origami with jeopardy, because the only story I can tell about it is of frustration and gluing my fingers to it or burning my fingers as I solder it. And so what I really, really want are things like Airfix kits. I made loads of Airfix kits as a kid. I really loved them. And actually, I want to make Airfix kits of really, really niche objects. And finally, it looks like we can have these things that we want, and that things are lining up in the world that make it easier to assemble atoms into shapes of things. So Fred Wilson said this interesting thing about Kickstarter and saying it was actually a futures market for products, which kind of got me thinking a bit. Albert Wenger, who's one of the investors in Shapeways, said that Shapeways is manufacturing 2.0. And if you go and look at their booth, it's pretty obvious. And then Brie Pettis said something which I think is pretty important, which is about making it really good before we make it cheap. And I think everyone talks about disillusionment with 3D printers through really cheap ones. And also the Create and Craft channel has some amazing things that I discovered in the UK when I got chickenpox last summer and watched it almost continuously. Why is this interesting at the moment? Well, it's interesting because actually for mass-produced objects, China really isn't a long-term solution. For model railroads in the UK, everything that gets offshore to China turns up late or more expensive, or increasingly actually the moldings are bowed when they actually come to you in the box. So China really isn't a long-term solution in lots of ways. One particular way is to do with peak oil. So at the moment it's getting more and more expensive to ship stuff from China. The advantage is that when actually we don't ship stuff from China in these big container ships, we all get a free shipping container, because there are so many shipping containers out there at the moment. And then also in the UK, especially since the Olympic ceremony of last year, there's a strong feeling that we really want to bring engineering back. We used to do lots of great engineering. It was celebrated during the Olympic ceremony, and we can do it again. And the feeling is that we want to bring it back. But this time, actually, we've got the internet on our side, so we can make things faster, and things are brought closer together. And to illustrate that, I'll talk about how we made a kit. So we really wanted a kit of this wagon from the Dinorwic quarry in Wales. And it's an amazing quarry. It's enormous. Like, it's one of the biggest man-made objects in the UK. It's so big that they flooded a third of it to make a reservoir. And actually, you'd barely notice it. And it's the most amazing quarry because they used to make their own parts there. They had their own foundry. They made their own wheels and axle boxes. They even had a sawmill there. which fortunately doesn't work, or else my wife changing my son's shoes would be really rather dangerous in this picture. So we went and we measured some of their wagons really precisely. We took loads and loads of measurements and hundreds of pictures. We measured all of the parts, and we really got to understand how they made these wagons. And then we found someone on the Shapeways forum, a really great guy called VJ Paul, and we said to him, could you make us a kit? And so for starters, the internet had brought me and VJ together. Without him, before the internet, I'd have searched through the yellow pages for decades to try and find a 3D modeler. So that's gone amazing. And within 2 days, he'd actually made this representation of it. He'd made us this prototype kit. And actually, our plans are now more accurate than the published plans for this. So we're actually backfilling all of the sort of catalogue of measurements and plans with what we're doing. And with it being a kit, we wanted to know how you'd put it together, how you'd make it. So we coloured up the different parts we wanted, and VJ split the CAD file into different bits, and we got a sprue of parts, and we sent it off to Shapeways, and within sort of 2 weeks of us wanting to do this, we had a part that was in production in Shapeways. We had a kit in production, which appeared in the post, and within a month of us starting this project, we actually made one. And that was the most amazing feeling in the world, to have commissioned a thing that you've wanted for years and have it turn up in the post in plastic and you can make it. It was amazing. It now means that we can make tens of them, hundreds of them. And it's got an incredible feeling. And then, of course, we took it back to Wales to meet its big brother and sort of did a few silly photos. The cool thing about this, though, is that you can make them whatever size you like. So one of the big problems within model making is that these things come in one size due to injection molding costs. So all of the tooling to make all the things on this page, if we did it with injection molding, is around $50,000. And so for a wagon that was only used by one quarry in Wales, we're not going to do that. But 3D printing lets us make them any scale we want to. So we then started thinking, well, this is kind of interesting. I wonder if there's something in this. And we started thinking about lots to do with user centricity. I've worked in the web for a long while, and so the first thing you tend to do is think about users and what they want. So we tried to work out what the parameters were about model making and user centricity. So we felt it was about choice, so how big, how complex, and 3D printing hits that really nicely. And then in terms of kits, we wanted to make things that were not too hard, not too complete, not too perfect, but could be modified really easily, and that would take pre-existing parts like wheels and bearings and stuff like that, or even axle boxes that already existed. And then we started thinking about community, and we're now building a website which has got a community there where people suggest what they want kits of, and then if enough people want them, we go and make them. And then we started thinking about the explanation and the clarity bit, and that's what we're really working on now, is letting people tell the story of what they make as well as us telling the story of the kits. But last summer, I started thinking, well, actually, we could make a more complex kit. So once you've made one, you kind of think, well, what else can I do? And we thought it would be really cool to make a kit of a steam engine, a complete steam engine. And so, as I said before, 3 interesting things happened last summer. So the first one was that the Olympics happened and the opening ceremony inspired us all. I got chicken pox, which as an adult means that you spend a lot of time sleeping, and the rest of the time you don't go to work and you have time to think. And something quite amazing happened in the world of British Railways, which was these 3 quarry locomotives came home to Britain. So amazingly enough, they'd been shipped out to the US by an antiques dealer. They went to a museum. They stayed in the museum, in the sort of the archives of this museum that never happened, for about 45, 46 years. And then eventually it was decided that they could come back to Britain. And there was something really exciting about this, was that if you saw the pictures of when they left Britain compared to when they came back to Britain, they were essentially the same. So what we actually had was a time capsule. It's an amazing sort of time machine to go back to the quarries in Wales, which closed, before I was born. And when you restore steam engines, lots and lots of things happen to them that make them not quite how they are when you start. You replace loads and loads of parts. And so we decided that we had to spend some time cataloguing these amazing steam engines that came back before they got taken apart again as part of this process. And what we did was we introduced them to these interesting robots that we'd got whilst they were asleep in their museum basement. And the first one of which was a Gigapan head, which is a bit that came out of the NASA missions to Mars. And it's basically a photographic tripod head that moves in lots of directions. And so you take a whole load of pictures and you get an incredibly high resolution image out of it. So this is a half a gigapixel image of that engine. We couldn't actually do the other side at the time. The wall of the shed was a bit too close, so we got to go back a bit later in the year and do the other side. And we were really lucky, and we got a break in the weather in Wales. And for those of you who haven't been to Wales, this is actually a break in the weather in Wales. This is a nice day, even though it was chucking it down with rain. And we could do the other side. And we've now got these really amazingly high-resolution photos. So we've captured this thing and we've created a time capsule for future generations to enjoy. So you can see like the scratches on the brass of this engine where the engineman's hand would have operated it over its 80-year lifespan. And that's the thing that keeps amazing me about these things, is that these humble little engines worked very hard for 80 years. And they're effectively like a Victorian-era dump truck. And I can't imagine anything that we make now, well, let's hope that we're going to make things now that last for 80 years and that we mend for 80 years, because we kind of need to. So the second robot that we introduced Winifred to is a laser scanner. This is a Faro laser scanner. And we use these white positioning spheres, which you can use to register the different laser scans that we took. And in not much time, we actually started turning Winifred, this Victorian-era engine, into a digital object. And this is the laser scan of her that we took. So you can see everything in really great detail. We've got 1mm resolution of a Victorian-era steam engine, which allows us to do some quite wonderful stuff. We've actually, since then, we've done another set of steam engines at 0.2mm resolution. So we're capturing incredibly detailed data. We could then turn that into these really high-resolution CAD models. And in these models, we're trying to represent not the basic geometry, but actually all of the twists and bends of the pipes. Because lots of them were bent by hand. So we kind of want to know how that was done, because that's part of the history of these objects. We've also got really interesting details, like the dome has got some dents in it where somebody managed to drop a crane hook on it. And so we can now build a really accurate kit of this engine, complete with the dents that happened to it when it was in the mountainsides in Wales. And when we got this, we got really excited, and we sent off to Sculptio, who are here. Do go and see them. And they printed out a solid model for us, which we've got over there, which you can look at rotating in a case. And as a model maker, this was quite mind-blowing, really, that we could get this sort of level of detail off a printer. And we can now do much, much better than this. This is kind of crude. And we've recently done a model for a diesel where actually we're doing, on the left as you look at it, there's the actual real-life diesel. On the right, there's one of our 3D prints of the grille that we've got. So the printing is getting better and better all the time. We can capture more and more detail all the time with what we're doing. So we now call, the original engine was called Winifred, and we now call this Digifred. And so obviously we took it back to Wales and sat it with the engine itself. And the railway press got kind of excited by what we were doing. And they came along and they very kindly called me a techno wizard, which I now want a t-shirt that says that. But we mentioned at the start about making parts at a scale of 1:1. And here's Julian, who's the guy who bought the engine back from America, holding a 3D printed part that we could use to replace it. And I've actually got a metal one here. So this is a perfect reproduction of the latch off of a Victorian steam engine, printed in stainless steel. Costs about as much to print as it would to fabricate this part. So suddenly we have a way forward to really do sensitive restorations of these engines, where we can not only print a part that matches, but a part that contains the sort of patina and the wear of the original, but is fully functional. So coming back to this statement, which I really love, once we'd worked out how to do this, we felt that we ought to open up the process to other people, as I said. So we've built this website where lots of people can say, I'd really like this particular kit. And if any of you are modelers and you've wanted something forever, please go and put a project on the website, because that's what it's there for. And when enough people support it, we then put it onto Kickstarter, and we raised the money to go and make that kit. So we went to Wales again, and we scanned the oldest narrow gauge engines in the world at the Festiniog Railway. And there are 4 of them. You can see us doing some laser scanning here. So this is actually using the higher resolution head. We do several scans around the engine, and it gives us really beautiful point clouds like these. So this is the 0.2 millimeter resolution data of these 4 engines. And the cool thing is that these engines all started off being very similar to each other, but actually now they're quite different. And so we've got data on each one. So instead of building an average kit, we can build a perfect kit of each individual engine. And moreover, we're actually starting to repair these engines as well using the data. So the one on the right is called Welsh Pony, and it's one of the engines that hasn't been restored there properly. And it has a few parts missing. The parts have been given to sister engines and things like that. So we actually use 3D printing to create some new casting masters for brass parts. So these are for sand casting. These are the missing parts from the engine. And they've come back and they've been cleaned up by the guys at the Festiniog Railway. And so this is using shapeways as a way of generating the parts to make parts for steam engines. And the engine now looks considerably better than when we first went and scanned it as a result of some of this. And we're now starting to help the Festiniog make cab fittings, because lots of the brass cab fittings were taken off many years ago. So we've now got really great CAD data of all these engines, and we're starting to make the kits. We're doing lots of stuff to refine the resolution we're getting off the MakerBot. So these parts came off a regular MakerBot Replicator 2. We've just tuned the filament feed quite a lot to it, and tuned how we slice them. And we think it's a really kind of interesting space for modelers. If you want to come and see some of the refined parts we've got, please do. And in fact, this weekend we're doing our first kits that if you've got a MakerBot, you can pay and you can download the files and you can print as many of them as you like at home. So we think it completely changes the hobby. So the final use of this slide is to do with what we're doing next with all of this technology and other bits, which is we're experts on Welsh quarry railways, but we're not experts on everything. So we kind of want everybody who's an expert about something to curate and to work out how you build a kit of something they've always wanted and actually manage the process. So we're going to put the people that we've got who do all the CAD work in touch with the people who are commissioning the kits so that we can make lots of them. And for getting the data in, we've been playing with something really kind of interesting, which is called automated photogrammetry, which is a very long way of describing something where you basically take a lot of very high-resolution photos with a standard digital SLR, which lots of railway enthusiasts have, and you walk around an object and you take sort of 15, 20, 30 pictures, and the software reconstructs it into a 3D mesh. And actually very, very high resolution 3D meshes of things like this post box or this station sign or these fire buckets at a station or a chocolate machine or a wagon or even an entire station itself. So we've spent the last sort of year and a half, 2 years on a journey exploring both what technology we can get to change how we do our craft, but also how we can still have a craft in the place where there is all this technology. We don't ever want to replace a plastic kit. We could print this with the wheels in and they would rotate round and everything would be great, but actually the fun of having a craft is making things and refining things and gluing them together and occasionally making mistakes and learning from them. And that's certainly what we want to do. And we want to get more kids into it, which is why if any of you are from a school in the US, you can come by our booth and we'll give you one of our download cards, and you can then print out one of our kits on your school printer. I just want to say a few thank yous to nobody that you'll know, but people who've actually made this all happen. VJ designed our kits. Digital Surveys are the lovely people who did all our laser scanning. They normally scan oil rigs in the North Sea, so scanning a steam engine and a nice dry shed was a bit of a treat for them. And then Julian Burley is the guy who brought the engines back. And we need to thank all of the museums who've helped us. One of the things that we're doing with this project is, out of every kit that we sell, we're donating back to the museums so that they can keep doing what they do. They've created an amazing time capsule for us all to enjoy and explore. And so I think it's only right that we now use the technology that's all around us at Maker Faire and our skills as makers to help them in that mission. And thank you very much. I've got a few minutes for questions, I think, if anyone has some. So about 4 minutes. So. Yes, sir.
Can you talk about the software to take the images to the wire mesh? Is that something you're developing? Is that a commercial?
It's a commercial package. It's by a company called Agisoft. They're a Russian company. You can tell it's very well-designed Russian software because it runs beautifully multi-core straight out of the box. And it's called Photoscan. The thing that we're doing at the moment with it is we're getting it to work on cloud services, so that we can provision really, really big machines at a moment's notice to do the scanning, because it takes about sort of 20 hours of a quad-core machine to do a bench. So we want to try and make that scale a bit better. But no, it's a commercial package that anyone can buy. Any other questions? Cool. Our booth is just over there. It's within walking distance. It's sort of the sort of far right corner of that tent that looks like it's about to take off at the moment. So you can follow me over there. That's brilliant. Thank you very much for coming. It's been a real pleasure to be here.